All right, welcome back, everybody. Sustainable engineering, week 9, life cycle assessment. So I'm going to go through kind of a short PowerPoint about life cycle assessment. But I want to show you something first. Check out what it's doing outside. That's super fun. Today is Wednesday, so I'm a little late getting this to you. Sorry about that, but that's kind of been the theme of the whole term, right? So the way it is. All right. Let's go through the PowerPoint, talk about life cycle assessment. So it can also be called life cycle analysis. You'll hear both terms. So this could be a system that is active at the place you go to work. So that's why we cover it, just so you kind of understand the 4 major areas of a life cycle assessment. A lot of folks, when they hear life cycle assessment, they think, oh, do we recycle it? And that's a very small portion to the full life cycle assessment. So let's look at the calendar real quick. So I kept it here, even though this is today on the 8th. This is the lecture that you're currently watching, and then I'll talk about the homework that you're going to do. It's not due till the 12th, that's Sunday, so you got some time there. I will create another lecture, and there'll be another little homework piece for you. So, all right, let's look at the PowerPoint from the beginning. And maybe I'll even do a slideshow. It might look better. Yeah, check it out. Perfect. All right. So let's just kind of revisit sustainability. Again, this is from the United Nations. They're indicators of sustainability. So on the left, you can see the issues. Greenhouse gas, ozone layer, air quality, deforestation. Why is that a problem? Because we get most of our oxygen from the forest. And it's a huge carbon eater. So plants eat that carbon out of the air for us. So we have good clean air. So it's a big problem when we deforest. We have desertification, which means we have areas turning to desert, drying up. Agriculture, biodiversity, toxic chemicals, non-renewable materials. So fossil fuel would be a non-renewable. Hazardous waste, waste volume, and then water. Okay, so here's their indicators of sustainability. Poverty. We cannot have increased poverty at the rate that we currently have. It's not sustainable. Gender equality, nutrition, child mortality, sanitation, health, education, housing, crime, population, and employment. Those are all their kind of indicators of sustainability. If we were green in all these areas, then we would have a more sustainable and potentially a sustainable system to live within. Okay, economic is money. We do need that, right? We need employment, the environment, and then social. All 3 rungs of their sustainability diagram. All right. So the effects of waste, let's talk about that, because that's one of the big issues is we are creating an enormous amount of waste in which typically we bury. That's what we do, right? This can affect surface water, groundwater, soil contamination, air contamination because of the gases released into the air, and leaching of these potentially toxic materials, right? Check this out. Number of years to biodegrade. Plastic bottle, 1,000 years. Those of you that use plastic bottles should stop. I have stopped many, many years ago. If it's in plastic, I will not buy it. If it's in aluminum, I will buy it. That's 100 years, and that's better than 1,000 years, and it is very recyclable, okay? All right, Glass bottles also 1,000 years. When we bury it in the ground, it's there for a very long time. Plastic bags, a little thinner. They do break down faster, 800 years. Batteries, aluminum cans, tin cans, nylon fabric, biodegrades pretty good. Leather shoes, biodegrades, 50 years type of thing. Wool socks, almost can't read it. And fruit peel, can't read it. And paper, can't read it. So clearly some things biodegrade much better than other things, right? Things to think about. All right. What are the issues? Greenhouse gases are an issue and temperature rise. So regardless of whether you believe this is a natural cycle, the planet is naturally warming because it goes through these ice age and non-ice age cycles. Potentially that's true. But if you look at the Industrial Revolution, which happens exactly at the same time that our temperature has really spiked on the planet, I think you can correlate that humans make an impact on global temperature. Are they creating it all? I don't know. But we definitely impact the temperature. So that's not good for our sustainability in the environment. Pollution's the problem also. This is parts per million, concentration of CO2, right? And we're way up here. We're past that. So not good. Very, very not good. All right. What is a life cycle assessment? A life cycle assessment is a technique, and this is important that you kind of understand the definition, for assessing the potential environmental aspects and potential aspects associated with a product or a service. So either one, a product or a service, or and you can go on and on and on, a manufacturing process, which is what you're going to do for your homework. You're going to do a life cycle assessment on a manufacturing process. Okay, so the steps, you got to define what you're going to do. That's kind of that first statement. And it can be big scope, it can be little scope. So it can be just on one process in a manufacturing facility, or it can be on the entire manufacturing facility, or it can be on the product. Okay. What we do is we define it and define its scope. That's critical. Then we compile an inventory of relevant inputs and outputs. So what are the inputs to that system or that product? That can be a water input, that can be air, that can be, all these things are used in the facility, right? That can be materials in, that can be electricity in, it can be number of manpower hours, right? It can be a lot of different relative inputs. And then the outputs would be, dirty water out, warm water out, dirty air out, or clean air out. I mean, they can be good outputs also, right? Scrap material would be an output. Things that are getting dirty that need to be cleaned, that's an output. So this is a big step. This is like the biggest giant step, is to try to inventory the relevant or important inputs and outputs. Okay. The next step is evaluating the potential environmental impacts associated with those inputs and outputs. So if you have an input that is water and an output that is dirty water, then you would need to evaluate the environmental impacts of that one input and output, right? If it gets output to the river and it's warm water, then that's going to impact all of the life in the river, right? It's going to raise the temperature of the river. So this is a big step also, because you go back through the inventory and you try to evaluate the potential environmental impacts of those inputs and outputs. Okay, so those two steps here and here are the big steps of an LCA, right? In the end, you just interpret the results of the inventory. Hey, this is bad. we need to change this. Oh, hey, this is good. We're doing good here, right? So we just interpret the results of the inventory and the impact phases. So this being the inventory, this being the impact phase, right? It's a study. So it is designed, and LCA is designed to look at a system or a product, collect the inventory, collect an inventory, the inputs and outputs, right? Evaluate those inputs and outputs, and then write a summary basically on, hey, this is our situation. We should, it can have recommendations, but it doesn't have to. A lot of times an LCA doesn't have recommendations. It just pulls out the data, right? And just says it how it is. Okay. All right. So goal definition, that's the first part. And that's super important that you write the scope of your LCA. Like, it's the LCA is going to be contained around this process, right? The inventory, quantifying the energy and raw material inputs and environmental releases associated with each stage of production. So this can go deep into subcontractors outside of the process. So you have to decide whether that's in your scope or not. Like if I'm going to make beds, right? And I'm going to make these beds out of wood, then if I do a life cycle assessment on my entire product, the bed, then I might have to consider where I'm getting the wood. And so I'm getting the wood from a lumberyard maybe, but where are they getting the wood? Maybe they're getting the wood from Roseburg Lumber. And that location is in Roseburg, right? So the wood I use comes from a tree at the coast, gets transported to Roseburg Lumber, gets milled, all of that energy to mill it and turn it into lumber to transport it from the coast to Roseburg. And then after it's done with that, it gets transported to the lumberyard near me. And then I go get it and transport it to the place where I'm going to build the bed, right? So the LCA can go that deep. It can go into material acquisition, and it can go into, subcontracting that goes on before I get my material to work with. So it's huge. Like Patagonia has gone next level, and they've gone all the way to the raw material with their LCAs, right? Very few companies do that. So in your homework, you're going to have to decide how far you want to go with the materials that you're going to use in your manufacturing process. Okay. And then an impact analysis, assessing the impacts on human health and the environment associated with energy, raw material inputs, and environmental releases quantified by the inventory. Okay. And then in the end, it's an analysis. And typically it's an improvement analysis. Like, hey, this is the situation. This is how it's currently done. And what can we do to improve it? So I'm going to want you to have an improvement analysis also. I know you're probably just dying to know what you're going to do it on. All right. So let's just think about this a little bit. Extracting raw materials, manufacture of raw materials, transportation through the life cycle, any packaging used through the life cycle, manufacturing process, storage, the product's use, the product's disposal, or any part of it, right? Maybe not the product, maybe the product gets consumed, but you have the packaging left. What happens to that, right? So it's unimaginable how big these LCAs are for a large company. Fortunately, your process is pretty small, yet you're still going to have a substantial LCA. Like it's not going to be huge, but it's going to be pretty in-depth, I hope. All right. One more time. Goal definition. The basis and scope of the evaluation are defined. So do that for me. Inventory analysis. Create a process tree in which all processes from raw material extraction through wastewater treatment are mapped out and connected, and mass and energy balances are closed. All emissions and consumptions are accounted for. Try to do this for me. So you may have to go through your system taking notes, but go through the entire system. Acquisition of raw material, the manufacturing process, and then whatever else happens, packaging, cleanup, and what resources get used during that process. All right, that's the inventory. And then impact, look back over your inventory and say, okay, at this stage, this piece of the inventory, this is the effect. Okay. And then in the end, write me an assessment, hopefully an improvement assessment. So you got to go through it as you normally would so you can get a fair LCA. Don't forward think it, just go through the process. All right. I'm going to zip through this and get to your assignment, which is here at the top. You're going to create an LCA for a peanut butter and jelly sandwich. I guess if you're allergic to peanuts, you can substitute in something other than peanut butter. So you're going to make a peanut butter and jelly sandwich. You're going to manufacture it in your kitchen, and it's going to be for your lunch later in the day. So you're going to make it in the mornings for your lunch later in the day. Okay. I do want a flow chart of your manufacturing process, as much detail as possible, right? And I do want an inventory. And then I want an impact analysis, and then I want an improvement. All right. So you have until the 12th to pull this off. Good luck with your LCA. All right. You got to go through the process, take lots of notes through the process, all the way through, including waiting till lunch to break it out, to eat it, to then what happens, when you get back home type of thing. Okay. All right. Good luck, and have fun with it, and post it up. I have a submission area, so we're ready to go. Stay warm and be careful out there because it is still snowing. So, wow, I'm not sure this was forecasted. Check it out. Yeah, still snowing.